Please welcome Nicholas Gerasimatos, Technical Cloud Evangelist of Red Hat.
Thank you. It's actually a very privilege and honor to be here. You know, Microsoft and Red Hat have had such a strategic relationship. And whether it's with cloud computing or hybrid cloud or platform as a service, things along those lines, we're really kind of pushing the technology much further ahead than we were previously. Today, we'll actually be showing and demoing Red Hat OpenShift container platform running on Microsoft Azure. So let's talk a little bit about Red Hat and Microsoft better together. What have we really done? What have we built? So Red Hat and Microsoft both believe in the power of an open ecosystem. That is given and known. Whether we're working together on deep integration between shared solutions or optimizing Red Hat Enterprise Linux workloads on Microsoft Azure, customers get many advantages of our collaboration. In the last year, we've announced some pretty amazing things, from .NET Core to Microsoft SQL Server running on Linux, and then also, definitely helping push the technology further with solutions like OpenShift Container Platform, which can run on top of Azure. So it's pretty interesting, right? We live in a software-driven world. Mark Anderson famously said, "Software is eating the world," and it's certainly ringing true today. Today's dynamic business companies need to make effective use of the resources, but they also need to make sure they're doing so across critical areas that not only accommodate, but encourage innovation and agility. Oh, and of course, businesses want to do more with less, right? That just seems to be the common theme. Less than a decade ago, we began a paradigm shift towards platform as a service, software as a service. And it seems now more than ever, we're actually living in this software-defined world. Connected cars, online retail, home automation, using communication solutions like Skype or other ones like WhatsApp or whatever. It's obvious that software has dramatically changed our lives in every single way. However, all these benefits have actually led towards us needing to adjust the way that we have been building applications and infrastructure in the future. So how has software become so pervasive? If you look back to the 1960s, it was a virtuous cycle whereby improvements in infrastructure and technology made previously intractable problems solvable, right? The birth of the x86 application platform led to falling costs when it comes to mainframes, distributed architecture, distributed platforms, and decoupling mainframes from the entire thing. Really, what it did is it helped evolve the maturity of applications in x86 and cloud computing. And that's how we got to where we are today, right? Since all these improvements happened in parallel, though, new technologies began to emerge at an incredible rate, a larger rate than I think anyone actually is even comprehending. Digital transformation, public and private cloud, hybrid cloud, hosted services have all led to the rise of cloud computing becoming mainstream. Some of the services that we use every day have shifted our expectations as to what's possible. Simply put, our expectations have changed. We want the ability to use any software at any time, anywhere, without the burden of a maintenance window or unexpected outages. We are living in a world of perpetual beta, in a sense. These open ecosystems have also allowed engineers to have the ability to be able to choose the best tool for the job rather than being constrained by whatever is available from the underlying platform. We learned that open ecosystems yield better outcomes. Despite all this rapid innovation, customers are also demanding data be secured, that it's highly available, that it's redundant. They want it always on. They want it always accessible. So the best companies deliver better software and they do it faster, right? These changed expectations have led to the simple reality. Companies that deliver better software stay in business. If you don't, well, then you don't exist. To deliver truly great software and exceptional digital experience, you need to understand application performance, the customer's experiences, and how software is impacting the business. Companies overall need to reduce time to validate builds so that they can actually promote things to production sooner. They need to reduce these testing efforts by using automation and orchestration to essentially decrease the time that it takes them to actually get these products to market. They need to detect bugs in applications sooner in the development cycle. This is specifically because NASA actually did a study, and in the study, NASA noticed that depending on the time it takes you to actually determine and find a bug in your software, it actually costs you more to actually go back and remediate it, which is incredibly interesting. And then obviously human error, right? We know humans are imperfect. And so by repeating and building automation and doing testing through automation and resetting these environments back to a no-fault state, you're able to actually guarantee your code is better and you're really empowering your developers. So what's the common thread, right? I'm talking about cloud computing and all these other things. The best solution for many clients is probably going to be a hybrid cloud approach, at least currently. Leveraging the power of both the public and private cloud infrastructure using a common operating system between either of the two different locations. And the reason why I say that is because for the most part, you don't want two disparate different operating systems to manage because that's twice as much work for your operations team. By taking advantage of the ability to mix and match the best elements of private and public cloud by doing the hybrid cloud, companies can leverage greater flexibility and benefits from rapid innovation. Finally, as with emerging technologies, it's important to align with cloud ecosystems that are based on open technologies in order to maintain choice and vendor flexibility. And remember, infrastructures matter. You hear from many different people that infrastructures don't matter. They absolutely do. Regardless of which type of cloud model you choose, it's the key element for your overall cloud strategy and business strategy. So Red Hat OpenShift, what is it? What's it do? How does it make your life better? So OpenShift lets you easily and quickly build, develop, and deploy into nearly any cloud infrastructure. Private, public cloud, doesn't necessarily matter. Hybrid cloud, Microsoft Azure. OpenShift can even be deployed as a managed offering in public clouds. And another interesting thing is you could actually run OpenShift on your own laptop. Red Hat offers both of these solutions with the OpenShift Container Platform dedicated and OpenShift Container Platform online. So regardless of which deployments model of OpenShift containers you choose, you'll have an award-winning platform to get your next big ideas. And OpenShift makes running an enterprise-grade container platform easier, more simplified. It's open, it's extensible, it's portable, it's automated, it allows for collaboration between different developer groups. And since it's built on Kubernetes, it's designed to handle orchestration and management across clusters from very, very small to gigantic. There's a lot of big companies that are using Kubernetes, and we don't even realize it in our daily lives. So how does OpenShift extend our reach? From an infrastructure perspective, OpenShift containers rely on Red Hat Enterprise Linux, which is trusted by pretty much all of the major Fortune 500s. We use features like control groups and namespaces. We use SE Linux to isolate slices of the underlying operating system. And the great thing about containers is that they're easier to build and consume compared to virtual machines. This allows us and enables us to run many containers on the same infrastructure and increase utilization that would otherwise be wasted. While containers provide many benefits to infrastructure, they also pose a little bit of complexities. So as you grow, as your environment gets larger, you have to start developing orchestration and figuring out how to manage at scale. From an application perspective, containers are a way to package and single entire application and all of its dependencies into this self-contained artifact that could be deployed in any location. It's easy to package applications that are already built. It's simple to share these applications across your organization. And developers have full control over the content and can package most everything and anything for running inside a container. So OpenShift also helps your operations teams deploy an enterprise-grade container platform. A lot of times we have people that come to us and they say, well, if a lot of this stuff is open source, why can't I just take some of these things off the shelf and put them together and everything works? And the truth of the matter is you could do that, but when something breaks, who's going to support it? Who's going to help you get through these trials and tribulations, right? And it's really important to realize that having an enterprise-grade platform when you're running business mission-critical applications and you need support, it's imperative. Our operations staff are here to enforce fine-grained policies, leverage the power of Red Hat stability and support. And the important thing to know is that we're here for you when you need us, right? So for operations, some of the benefits, monitoring, automatically managing applications, automatic scaling up and down according to workloads. No more 4 a.m. calls saying this one server's exceeded its utilization and someone needs to go and fix it. Automate it. Enforce fine-grained policies for authorization, networking, and multi-tenancy. So when you're looking at compliancy-based stuff, it actually is integrated in there. And then obviously services and support from experts across the stack, right? OpenShift is actually built on top of Red Hat Enterprise Linux, which is the most trusted Linux that's in existence. And so you're really getting all the benefits of our support and our builds and our community. For developers, it's a little bit different. OpenShift enables developers to have full control over frameworks and runtimes without making things overly complex. Developers can create reproducible images which could then be shipped and ran in any OpenShift cluster without worrying about the underlying infrastructure. This could be Microsoft Azure, it could be your own data center, it could be in a hybrid cloud infrastructure. OpenShift provides developers a graphical interface for those that prefer such. It makes it easy to deploy containers since you have a web console or command line, or you could use the APIs. And it has deep integration when it comes to continuous integration and continuous deployment solutions, such as like Git, Subversion, things along those lines. So continuous delivery pipeline, right? This is the holy grail. How does a deployment pipeline look like when you're using OpenShift? What are the benefits of continuous integration, continuous deployment, CI/CD? It all begins with developers committing a change to a source repository. Source repo is actually where you're storing all of your code builds. The CI/CD engine, for example, let's just say Jenkins, gets notified, which triggers a download of the application code from the source repo and rebuilds the application with the newly committed changes from the developer. With containers, the CI/CD engine at this stage will package the application as a container image all in one with all of its individual dependencies, and that can be deployed in a target environment, and it runs exactly the same of where the environment it is. Once again, completely agnostic infrastructure. Quick, simple, painless. Public cloud services, such as Microsoft Azure, when bundled with solutions like OpenShift for platform as a service and infrastructure as a service and containers as a service, it allows you to embrace shared infrastructure to handle critical but tedious jobs like continuous delivery and continuous integration, monitoring, metrics tracking, authorizations, all of these things that just are so monotonous to actually deal with on a daily basis. So what we're really trying to do is we're trying to lessen the roadblocks for developers to write their code and get their code out the door as fast as possible. And by doing that, it also increases the value of business. I have a pre-recorded demo that I actually would like to show you. So let's jump into it. So what I wanted to show today is a little bit about OpenShift. OpenShift is actually very flexible, so it could run on any individual cloud. It's agnostic to the infrastructure. You could run this on your laptop, you could run this on Microsoft Azure, and you could run this in your data center. So you could actually embrace a hybrid model. The great thing is the Red Hat Developer Suite, which we released recently, has the container development kit built into it. So it's a single click button to deploy OpenShift on your own laptop to start your development process. So as you can see here that I've highlighted, this OpenShift installation is actually running on my local laptop. This one's running in a private data center, and this one's running on Microsoft Azure. And let's go ahead and see what we have going on in Azure. So we have a couple projects in Azure. Looks like somebody was building WordPress, and we have some CloudForm stuff, and we need to go create some new projects. So let's go ahead and do that. So first thing we want to do is we want to build out the projects. And you do that through OC new -project dev -- display name, and then specifically the display name that you want for the project. Something that's easy to understand. Okay. And then the next thing we want to do is we actually need to allow Jenkins to have permissions to access the OpenShift APIs. So you're going to do an OC policy, and you're going to add the role to the user specifically. In this case, project is CI/CD, and then Jenkins is the user that we're actually giving access to. And then let's see. We're going to go ahead now and run this script. So what this script actually does is it does a git clone. So it's actually going out to Git, it's pulling down all of the information, and then it's actually storing it on my local laptop. And so what we want to do is we want to go to the OpenShift CD demo. And here we're going to actually run the command. So OC process -f CI/CD. dash template YAML, and then we're going to pipe that to OC create dash F. Okay, and now what we're seeing is that command actually pulled all of the images. So this YAML that's in here, let me go ahead and cat to that YAML for you real quick so you can actually take a look at it. This holds all of the information for the environment that we're building out right now, down to the very, very, very fine details of deploying the pods, when it comes to setting limitations of resources, things along those lines, right? And so let's see what we have here. Well, it looks like everything was built out. We have our CI/CD, and we have a dev and a stage environment. Let's see what CI/CD is showing. So it looks like it's in the process of still building everything out. Let's take a look and see what we have for events. So it looks like a couple of these guys are running really slow with building. You can see the details here that are going to be assigned. And it looks like the GOGS install is running. Let's go back. So it looks like we have some of them up now. The Jenkins server is up. The Jenkins backend is up. Postgres has now been deployed for the SonarQube. And Nexus is being deployed, and GOGS is coming online now. So let's take a look at our Jenkins pod. You could look at the environment variables. So enable OpenShift auth is set to true. So it's going to use single sign-on between the Jenkins server and OpenShift. If we go back over here and we click the Jenkins CI/CD, we see that Jenkins is tied in. So let's go ahead and log in here. And we see that Jenkins is set up, and it looks like there's a CI/CD task pipeline that's already been built. So if we go back over the console and we go to application or go to builds, we see there's no builds currently. If we look at the pipeline, there's a pipeline that's created from Jenkins, but it's not running yet at this point. We're going to actually get that running in a second. So the next thing we need to do is make sure all the other services are online before we actually start building some stuff out. So if we go to GOGS, GOGS should load, which it does. And here's our repo for our code, right? OpenShift tasks. This is something that our developers are working on. And let's look at Nexus. And you can see Nexus is holding our repos, but under here, there's actually no snapshots currently. And then we want to take a look at SonarQube. And SonarQube, obviously, as you can see here also, there's no projects built currently. So what we're going to do is we're going to build a project. So if we go into OpenShift and we say pipelines, a pipeline is essentially a way for you to matriculate your code from development all the way to production, or to a staging environment where you can then roll it out to production. And usually this is really great for developers to actually use because it helps them decouple themselves from operations and having to use operations for time. So we'll start the pipeline. And when I start that pipeline, you actually notice in Jenkins that it also started a build. And this is the console output of the build. You could actually look at it through here, or you could actually look at it also through OpenShift because they're tied in together. So this build is going to run it's going to take it a couple minutes, and hopefully it succeeds. Now, while that's actually running, let's go ahead and take a look at some of the information. So OpenShift stores all of your individual secrets that you are using for authentication. It has your configure maps, your memberships. If you had a quota specified on the user, you would actually be able to see it here. There's no builds to show currently because we're not building anything. And these are our images that we actually pulled down and built from. So the SonarQube image, the GOGS image, and the Nexus image. If we look at deployments, you can see the deployments that we recently have done. So you can actually see the GOGS, the Jenkins, Nexus, and then the databases that are backing things up in Sonar. And then if we look at the pods, we see a listing of all individual pods. Now, pod is a representation of a service or an application in a sense. And then here you can actually see the services, and these services actually manage the pods. And the reason why I say they manage it is if you actually go through, if someone accidentally, inadvertently deleted this pod right here, the service says that there's supposed to be at least one pod running it all the time. So if someone deletes it by accident or maliciously, the service will notice that that pod has actually failed, and it'll go ahead and it'll restart that pod again. So let's take a look at how our build's doing. Awesome, looks like it's ready to go. So it's sitting here and it's waiting for us to actually promote it to staging. So I'm gonna go ahead and I'm gonna promote that to staging. And if we go back into the console here, we go to CI/CD, and you look at the tasks dev, because it's been promoted, it's now in the development environment. And then if you look in the staging environment, it's either built or building. It looks like it's already done. So we just actually completed a build of software. That's only one thing. Let's go ahead and have some fun. Let's break things. So we'll go into Jenkins. Make sure that everything is ready to go in Jenkins. And then we're going to go into GOGS. And we're going to go into the EAP branch. And this developer, I know that he likes to write really bad code. So I'm going to go ahead and I'm going to tinker with this code and see if I can figure things out. So we're going to go to source, test, Java, org, JBoss. Yes, and the quick starts, and taskers, and service. And we're going to go to the user resource test Java. Now looking at this, looks like an old pretty standard build. But wait, there's this interesting ignore line. I wonder what that's for. Well, let's find out. So we're going to edit his code. Now, the cool thing is, once we edit his code and we commit this change back to the repo, OpenShift, because it's talking to Jenkins and it's talking to the repo, it knows that there's been a build that's been instantiated. So it'll actually grab it and pull it out, and it'll rebuild that application again, just by a single change from a single developer. So we committed that change. Let's see what Jenkins is doing. Well, we see it's building again. And it looks like it's getting started. If we go into OpenShift, you could actually see in the CI/CD, you can go to the pipeline here too. You don't have to go into Jenkins. You can see it either way. Looks like it's taking a few minutes to build. While it's building, let's look at a couple other things. So these are our applications that are deployed. And these are actually our pods that are running. And routes is actually one of the most interesting things. So when you actually deploy a pod, it's actually not exposed and accessible externally, right? You actually have to create a route so that people can actually route traffic to the pod or consume the application. Let's see where our build's doing. Oh, looks like our build failed. Let's take a look and see what's happening here. Well, it looks like there's no shell scripting for it. But you know what? I know this developer. I know exactly where he made the mistake. So let's go ahead and fix that for him. So we're going to go back into the OpenShift tasks. We're going to go to source. And we're going to go to the main branch. And we're going to go to Java and org, JBoss AS, quick starts, taskers, service. And then we want to go to user resource Java. Yep, just as I thought. He commented out all of the stuff that we need for our application to run. So let's go ahead and make that change. And mind you, you could actually do this using Git if you wanted to. You could just do a Git checkout. You could make the configuration change. You could do a commit, and you could push this up to Git as well. You don't have to use the user interfaces I'm doing right now. Some people prefer the UI, some people don't. But that's the great thing about all of these different solutions is anyone who wants to use a user interface with OpenShift, we have it for you. Some people who want to do APIs, we have that as well. And some people who want to do command line, we also have that. So let's commit this change. Hopefully this fixes it. So we see, if we refresh snapshots, we see the first build that we did. So it looks like that build went fine. Let's look at pipeline. So now we have that after we did and committed that last change, now it's in the process of building out another version of that software, that application with the changes that I put in. So we removed those forward slashes because they were commenting out code that we actually needed to use to run our application. And by looking at this, it looks like the build is actually succeeding. Oh, nope, looks like I messed up on the code. We're gonna have to go take a look. Oh, I see where I made a mistake. It's a user error. I entered the wrong branch. Looks like the developer's not the only one who makes mistakes. Let's commit this change. And let's watch Jenkins run again. And this time it should complete. Let's take a look in here. We can see the builds that are going on for the pipeline. So we see it's completed the first portion. This is the code that is pulled. So the build strategy is Jenkins pipeline. The source type is none. If it was a certain source type, you could specify that. So far, it's looking a lot better than it did before. Well, it looks like it passed test. We're getting closer. It's pushing to Nexus. Looks like it's going to deploy to dev. It's slow. Must need coffee like I do. And it looks like it completed. So now it's asking me once again, can I push this to staging? I think so. I think we figured it out. So it went ahead and it pushed it to staging. So now if we go in, we see in Jenkins, everything turned out fine. If we look in SonarQube, let's refresh this. You can actually see the application. If we dig into the application itself, we're able to see if there's any vulnerabilities that need to be addressed. Looks like there's 8 bugs and 1 vulnerability. My developers aren't doing a really good job about keeping this code maintained. If you go into the Nexus repository, you can actually see in here that the builds that we completed are actually live. These are all the builds that we completed that were successful. And the changes were all committed into GOGs at the same time, so multiple users could be working in this directory. And there you go. That's a continuous integration pipeline from beginning to end with just a few small scripts and then running on Microsoft Azure. So I just wanted to thank all of you for coming out today. I hope you enjoyed the demo. If you have any questions, please feel free to reach out to anybody in the Microsoft Azure team or at Red Hat. We'd be more than glad to talk to you more about OpenShift and how our solutions integrate directly with Microsoft Azure. It's been a pleasure. Thank you.